Good morning, students. In fifth topic, part A, relationship between zeros and coefficients. I am taking linear polynomial today. If alpha is the zero of the linear polynomial, p of x is equal to ax plus b, then what is the zero? Alpha is equal to, this is 0. 0 is equal to 0 is equal to minus b by a. What is minus? What is b and a here? Minus b is nothing but constant here. Constant. This is constant. Constant. This is and by a. What is a? Coefficient of x. Coefficient of x. What is a here? Coefficient of x. Okay. Now we have to show that if alpha is the zero of the polynomial, then we have to show that alpha 0 is minus b by a. This is the relationship between 0 and coefficients. See, if alpha is the zero of the polynomial, then we can write what is p of x. We can write if alpha is the zero of polynomial, then you can write p of x is equal to k into x minus alpha. You will have a doubt, what is k, sir? I will tell you. In example, I will take an example so that you can understand why I have taken k. Many students ask me that doubt. What is why you have taken k, sir? I will explain. Now, see what is px already. What is the standard form of our linear polynomial? That is, this is you take 1. What is linear polynomial? What is the standard form? Ax plus b, and this is 2. This is standard form of linear polynomial. See, what is the standard form of linear polynomial? We have ax plus b. If alpha is the zero of the polynomial, then what is the linear polynomial? We have k into x minus alpha. Then you see equating. We have to equating 1 and 2. We have to equate them. See, both are p of x. That's why ax plus b is equal to k into x minus alpha. See, this can be written as ax plus b is equal to k into x, kx, k into alpha minus k alpha. See, now comparing like terms, comparing the coefficients. These two are like terms and these two are like terms because x coefficient. See, now you can write ax is equal to kx. You write comparing like terms. Like terms. Ax is equal to kx. Your xx cancel implies a is equal to k. K is equal to a. We have k is equal to a. Now you take these two constants. B is equal to, you take b is equal to minus k alpha. What we have to show? Alpha is equal to 0 is equal to minus b by a. Say b by minus k is equal to alpha. It is nothing but alpha is equal to minus b by k is equal to minus b. What is k here? We have k is equal to, we got k is equal to a. You substitute here, the value of k is a. See what you got? Alpha is equal to minus b by a. Means, see, 0. 0 means alpha. 0 alpha is equal to, you got minus b by a. Minus. What is b here? B is constant by. What is a here? It is coefficient of x. Of x. Like that, I will take one example so that you can understand easy.
Now I will take one example, relation between 0 and coefficients of a linear polynomial. I will take linear polynomial. If x is the 0 of the polynomial, don't confuse, x is 0 of the polynomial. Alpha is also 0 of the polynomial. Don't confuse. X and alpha are same. Now relation between 0 means alpha is equal to minus b by a. This is 0. This is 0 and these are coefficient. What is alpha? Alpha is nothing but 0 is nothing but minus constant minus b by a. Minus b means what is the standard form of linear polynomial? Ax plus b minus what is b here? B is constant by what is a here? Coefficient of x. Now see, first we have to find the value of x, that is alpha. What is the 0 of polynomial? It is the value of x for which p of x is equal to 0. See, p of x 0, 3x plus 2. 3x plus 2 is equal to 0. 3x is equal to minus 2. X is equal to minus 2 by 3. What is the 0 here? Or 0 or alpha. What is it? Minus 2 by 3. Now we have to verify the relation between 0 and coefficient. What is 0 here? Minus 2 by 3. 0, 0 and 0 is equal to minus b by a. This is 0. What is 0 here? LHS. This is LHS. 0 is LHS. X or alpha. What is it? Minus 2 by 3. We have to prove minus b, RHS also, minus b by a should be equal to minus 2 by 3. We have to verify. Say, this is RHS. RHS. What is it? Minus. What is b here? This is, in this example, 2 is minus, b is 2. Because it is in the form of ax plus b. B is, it is standard form of, what is the standard form of linear polynomial? Ax plus b. It is in the form of ax plus b. What is b here? B is 2 minus 2 by, what is a here? A is 3. As we got LHS is equal to RHS. Verified LHS is equal to RHS. We verified relation between 0 and coefficients. Hi students, relationship between zeros and coefficients of a quadratic polynomial. I have already told you relationship between 0 and coefficients of a linear polynomial, and already also I told you that I would tell you the secret of k. I will take an example. I will tell you what is the secret of k after this relationship between zeros and coefficient. What we have to prove? See, if alpha, beta are zeros of the quadratic polynomial ax square plus bx plus c, then what is the relationship between zeros and coefficient? Alpha plus beta, sum of zeros is equal to minus b by a, and product of zeros c by a. Now I will tell you. Now see, what is quadratic polynomial we have? Quadratic polynomial p of x is equal to ax square plus bx plus c. This is number 1. If alpha, beta are zeros of quadratic polynomial, what is the quadratic polynomial we have? P of x is equal to k into x minus alpha and x minus beta. You see, and P of x is equal to, we have, if alpha and beta are zeros, what is quadratic polynomial we have? polynomial is equal to p of x is equal to k into x minus alpha into x minus beta. This is number 2. Equating 1 and 2. Equating 1 and 2. What we have? Ax square plus bx plus c is equal to k into x minus alpha into x minus beta. Now k into I will multiply this with this, x into x minus beta, x into x minus beta minus alpha into x minus beta, alpha into x minus beta. Now k into x, x square minus x into beta, beta x minus alpha into x, minus alpha x, minus into minus plus alpha into beta, alpha beta. Now k into, see x, this can be written as, I am taking minus common, minus x common, I will take x into, I will get alpha plus beta. How? X into alpha minus x alpha, x in minus into plus minus, x into beta, beta x plus alpha beta. We have what we have here? Ax square plus bx plus c. Now is equal to ax implies ax square plus bx plus c is equal to k into x square, kx square, k into x minus kx alpha plus beta, k into alpha beta, k alpha beta. We have to prove alpha sum of zeros is equal to minus b by a. Sum of zeros, that is the relationship between zeros and quotient, and product of zeros c by a we have to show. Now next, comparing the coefficients. This is kx square is equal to ax square. Kx, comparing like terms, comparing like terms are quotients. Like terms are quotients. Now ax square is equal to kx square. Ax square is equal to kx square. You see x square cancel. You will get k is equal to a. Next, I will take kx, bx is equal to minus kx into alpha plus beta. X cancel, b by minus k means minus b by k is equal to alpha plus beta. Now you have minus b by, what is the value of k here? K you got is equal to a. K in place of k you have to substitute a is equal to alpha plus beta. This is sum of zeros. Sum of zeros is equal to alpha plus beta is equal to minus b by a. Now we have to find product of zeros, that is c by a. Now you take constants, comparing the constants. C is equal to k, here I will take C is equal to k alpha beta. C by k is equal to alpha beta. We have what? K is equal to a, we have C by a is equal to alpha beta. Like that, product of sum of zeros, alpha plus beta, you got alpha plus beta, you got minus b by a. What is minus? These are zeros, sum of zeros, and minus, what is b here? Quotient of x. What is a? Quotient of x square. product of zeros, C by A. What is C here? Constant. By what is A? Quotient of x square. You take a note here. Here K and A are non-zero real numbers. Non-zero real numbers. They are real numbers. They should not equal to 0. You see, A is not equal to 0. A, B, C are real numbers because A is non-zero real number. Here K is also constant. It is a non-zero real number. K and A are non-zero real number. I will take one example so that we can understand. Now we will verify the relation between zeros and coefficients of a quadratic polynomial. Now what is the standard form of quadratic polynomial? P of x equal to ax square plus bx plus c. A is not equal to 0, a, b, c are real numbers. And what is the sum of zeros here? Alpha plus beta is equal to minus b by a. Product of zeros alpha beta is equal to c by a. If alpha beta are zeros of quadratic polynomial will have two zeros, alpha and beta, two values of x. Now I will take one example. X plus 4 and 2x minus 3 I will take. We will find the product of these two. Say x into 2x minus 3, 2x minus 3 and plus 4 into 2x minus 3 is equal to 2x square minus 3x plus 8x minus 12. See, you are getting 2x square minus plus 5x minus 3x plus 8x minus plus 5x minus 12. You take this quadratic polynomial and we will find out the zeros of the. What I have to do? We have to find the zeros. What are the zeros? Alpha and beta are the zeros. Sum of zeros is equal to minus b by a. First, we have to verify the relation between zeros and coefficients. These are zeros and these are the coefficients. What are the zeros here? We will find out. Again, and now I have taken 2x square plus 5x minus 12. I will take this example. I will take. What is it? 2x square plus 5x minus 12. I have prepared a quadratic polynomial. Then we have to find the zeros alpha and beta from this quadratic polynomial. Now see, 12 into 2, 24 minus 24 x square we have. How can you write 24? It can be written as 12 into 2, 8 into 3. It is better to take 8 threes out because you have 5 is there. 2x square, it can be written as plus 8x minus 3x minus 12. I split plus 5x like 8x minus 3x plus 8x minus 3x. You are getting 5x. If you multiply these two, we should get minus 24 x square. 8 3s are 24. Minus in plus into minus minus. 8 3s are 24 x into x square. Now you take these two, 2x common, x plus 4 and you take as it is minus 3 and you must get x plus 4. You are getting x plus 4 only. Minus 3x minus into plus minus 3 4s are 12. Now see what is the common here? X plus 4 and 2x minus 3. We have to find the zeros of this polynomial. What is the zero of the polynomial? It is the value of x for which p of x is equal to 0. Here you take p of x is equal to 0, implies 0 is equal to x plus 4 into 2x minus 3. Now we have to find zeros. X plus 4 is equal to 0. X is equal to minus 4. 2x minus 3 is equal to 0, 2x is equal to 3, implies x is equal to 3 by 2. What are the zeros here? Alpha is equal to minus 4. If alpha, beta are zeros of polynomial, alpha is equal to minus 4, beta is equal to 3 by 2. We have two zeros. What are they? Minus, you take LHS. Minus, or what is alpha? Minus 4 plus, what is beta? 3 by 2. We will find out LHS, alpha plus beta, sum of zeros. And we must get minus b by a, we must get RHS also equal to same LHS we have to get. 2 4s are 8 plus same 2 1s are 3 minus 5 by 2. Minus 8 plus 3 minus 5 by 2. We got LHS, how much you got? LHS you got minus 5 by 2. RHS also you must get minus 5 by 2. Let us verify. What is RHS here? RHS minus. What is B here? It is in the form of P of x is equal to, you write ax square plus bx plus c. What is a here? 2. What is b here? 5. What is c here? Minus 12 you have to take. Don't take 12. Minus 12. Minus, what is b here? 5 by, what is a here? A is 2. You got, see RHS also you got minus 5 by 2. It is minus, b means quotient of, b means quotient of x. What is a here? Quotient of x square. You got same minus. Therefore, we verified sum of zeros is equal to minus b by a. See, LHS, therefore LHS is equal to RHS. Alright, product of zeros. What are the zeros here? Minus 4. What is LHS? Minus 4 into 3 by 2. See, 2 2s are minus 6. What? You got LHS minus 6. RHS must be minus 6. What is C here? Constant. See, what is C here? Constant is minus 12. Minus 12 by, what is A? Quotient of x square? 2. You see, 2 6 are, you are getting minus 6. LHS is equal to RHS. We verified relation between zeros and quotient of a quadratic polynomial. I think you have understood. Of 2x square plus 5x minus 3, they are zeros are minus 3 and 1 by 2. If you want, I will tell you again. See, 2x square, it can 5x split middle term, 6x minus 3, x 2x I will take common, x plus 3 minus 1 I will take common. What is it? X plus 3. X plus 3 else common, you will get 2x minus 1. You have to, this is p of x. You have to find the zeros. X plus 3 and 2x minus 1. X plus 3 is equal to 0. X is equal to minus 3. 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to 1 by 2. You have two zeros. You know. See, these are, if minus 3 and 1 by 2 are the zeros of the polynomial, then what is the quadratic polynomial you have? P of x is equal to x plus 3 into x minus 1 by 2. Now I am not taking k there. I will find the product of these two, and also I will find the what are the products. See, it can be written as 2x square plus 5x minus 3 can be written as, what is the factors? Product of factors 2x minus 1 and x plus 3. If zeros are minus 3 and 1 by 2, what is the polynomial you have? X plus 3 and x minus 1 by 2. Now I am not taking k here. Now What is the product? I am finding the product of x plus 3 and x minus 1 by 2. And I am finding the product of the factors. What are the factors? Before finding the zeros, 2x minus 1 into x plus 3. I will find the product 2x into x plus 3 minus 1 into x plus 3. 2x into x, 2x square, 2x into 3 plus 6x, minus 1 into x, minus 1 into 3, minus 3. You have 2x square plus 6x minus x plus 5x minus 3. Product of the factors of 2x minus 1 and x plus 3. What is the product of the factors? You got 2x square plus 5x minus 3. Same thing we got. If you find, I am not taking k here. If you find the product of these two, you should get 2x square plus 5x minus 3. I will find the product x into x minus 1 by 2 plus 3 into x minus 1 by 2. X into x square. X into 1 by 2, x by 2. 3 into x, 3x. 3 into 1 by 2, minus 3 by 2. You see, I am taking LCM here. See, 2 is the LCM. 2x square minus x plus 6x minus 3. I am getting 2x square plus 5x minus 3 by 2 I am getting. See, the product of these two factors, if I take the product of the factors, I am getting 2x square plus 5x minus 3. Px polynomial, what we have taken, given polynomial, we got. After finding the zeros, I am taking the factor. After finding the zeros, I am taking the factors x plus 3 and x minus 2. I found the factors. I got to x squared plus 5x minus 3 by 2. If I take k here, k will be there here. If I take k here, I want to find 2x squared plus 5x minus 3. By which, what is the value of k? We have to substitute so that we get 2x squared plus 5x minus 3. See, k into k. What is the value you have to substitute? 2x squared plus 5x minus 3 by 2. 2 to cancel. You will get 2x squared plus 5x minus 3. This is the, like this we have to do. That's why we have to take k, that is mandatory. Now, if you don't understand this, I will explain again. 2x square plus 5x minus 3 is equal to, I am taking the same thing. What is the value of k? You have to find k into, if minus 3, this is quadratic polynomial we have to find the value of k. If minus 3 and 1 by 2 are zeros of the polynomial, what is the polynomial we have? K into x plus 3 into x minus 1 by 2. You have to take k, already I told you k compulsory, mandatory, you have to take. Now we have to find directly we have to find the value of k. This is method 1. What is method 2? Method 2 I will write. Method 2. Substitute x is equal to 1 both sides. 2 into 1 whole square plus 5 into 1 minus 3 is equal to k into, what is x? 1 plus 3. What is x here? 1 minus 1 by 2. Substituting 1 both sides so that we can find the value of k. This is method 2. Implies 2 into 1 square 1, 2 plus 5 into 1, 5 minus 3 is equal to k into, what is 1 plus 3? 4 into 1 minus 1 by 2, 1 minus of 1 by 2. 2 cancel. Now 2 plus 5, 7. 7 minus 3, 4 is equal to 2 into k, 2k. See, 2k is equal to 4, then k is equal to 4 over 2 is equal to k. Like that you can find the value of k. If you substitute k here, you have to take, now you can write, see, 2x square plus 5x minus 3 definitely equal to 2 into x plus 3 into x minus 1 by 2. If you multiply this with this and multiply it by 2, you will get 2x square plus 5x minus 3. That is the secret of k. I think you have understood the secret of k. You must take k. If alpha, beta are zeros of the polynomial, then that polynomial is p of x is equal to k into x minus alpha into x minus beta.